Welcome. This video covers using the readr package for reading in delimited data. We at this point know a little bit about how R is going to store data, right? We have vectors, we have data frames, and we have lists. We know that if we have nicely formatted sort of rectangular data, that a data frame is going to be really handy. Each one of the columns is really a vector of the same length, and so we can have columns of differing types, which again is a very standard way to have data. So how do we read in raw data? How do we take data that's not already in R and put it into some of these objects? Well, here's our plan. We're going to first look at how to read in clean delimited data in this video. And then in the next video, we'll start talking about how to read in Excel data, SAS data, talk briefly about how to connect to a database and read in JSON data, files as well. So common raw data formats, well, we talked about a few of them there. We have this idea of what's called delimited data. This is a pretty common way to store very basic data sets. And so delimited data means that there is a delimiter that separates the actual data values within the raw data file itself. And so, for instance, a comma might be used to separate the actual data values within that raw data file. And so we'll look at how to read in delimited data first. And then in the next video, we'll take on some of these other things like Excel data. Well, Excel is pretty common. How do I take an Excel spreadsheet and read that into say a data frame? We'll look at how to read in data from SAS, other software. Again, talk about databases and JSON. Let's again start with this idea of delimited data. Here are some examples of raw data files and what they might look like. In this first one, you can see that there are values representing, say, variable names in the first row. And then the second row are the actual data values, but notice that each one of these data values is separated by a comma, right? So this is what we'd call a comma separated value file. The comma is acting as the delimiter. And so usually you're going to see this type of file saved as a .csv file. .csv stands for comma separated values. So again, that's a very common way that statisticians store data, comma separated value files. We already saw this example here where we had a space delimiter. And so sometimes a raw data file that is space delimited will have an extension on it of .text or .dat. There's not sort of a .space or anything like that we use, like there is with .csv. And then over here, there's a tab delimited file. So rather than having spaces separate these things, this is actually a tab. And so this kind of delimited file will oftentimes be saved as a .tsv or tab separated value file, but sometimes it will also be saved as a .text. And then generically, right, a delimiter is just some character string that separates the data values. It doesn't have to be one of these standard character strings. For instance, here is a data file where a greater than sign is the delimiter. And so we'll need to be able to figure out how to read in something that's not sort of a standard type of delimiter. These kind of files are usually very generic as a .text or a .dat file. All right, so how do we read in these kinds of delimited data? What are our options? Well, there is a whole bunch of there are a whole bunch of functions from the base R stuff. So from the utils package, which is read in with base R, there are functions to read in delimited data. However, we want to immerse ourselves in this tidyverse. That's how we're going to approach this course. It's sort of the more modern way of doing statistics in R. So the tidyverse is just a suite of packages that all sort of work together, have nice syntax, and are user-friendly. And so there is this package called readr. This is part of the tidyverse. If you install the tidyverse and you load the tidyverse, you're going to load in this package here. Remember that you will need to install the tidyverse at some point in time. You only need to install your package once. That's the downloading of the files to your computer. But then every time you open an R session and you want to access the packages from the tidyverse, you'll need to use library or require on tidyverse. But again, if you do library of tidyverse, it will read in this readr function. This readr package. And so the readr functions that we have to import this kind of delimited data is given over here. If we have a comma separated value file, we're going to use read_csv. Now, you do need to be a little bit careful with .csv files. In Europe, they save things as .csv files, but those are actually semicolon separated files. So sometimes you'll see a .csv file somewhere, but it's actually a semicolon delimited file. And so in that case, there's this read_csv2 function that can help us out. Then read_tsv for tab separated values, read_delim for generic delimited data, and then read_table for white space. So we'll go through a couple examples using these functions. All right, we have this file called neuralgia.csv. That's our raw data file that has data that we do not have yet in R. So how do we read that in? Well, looking at it and seeing that it's a .csv file means that it's probably a comma-separated value file, although again, it might be semicolon, but it's probably a comma-separated value file. And so we just need to tell R where that file exists at, and then we can use the read_csv function to read it in. So how does R figure out where files are sort of by default? Well, by default, R is going to look in what's called the working directory. So WD stands for working directory here. And you can check what your working directory is through the getWD function. This will tell you where is R looking by default for files. And so for me, I have an R project here, but the file I use to create these notes is in this directory. And so when I run getWD, it tells me that this is where it's looking by default for files. Okay. If you want to set your working directory, you can either use code or you can use menus. I prefer to use code personally because it makes everything that I did reproducible. But if you want to use menus, that's fine. You can go up to Session, Set Working Directory, and then choose your directory that way. It'll bring up a little Explorer window, and you can go through and pick where you want R to be looking for files. Alternatively, we had getWD to figure out what the working directory was. Well, there's setWD to set the working directory. And all you need to do is give it a quoted string to the folder that you want to use as your working directory. So here I have a folder called datasets within the basics of R folder, which is within my repos folder, yada, yada, yada. So just give it the path to your folder that you want to use as your working directory. You might notice here that I have double slashes. That's because the backslash is an escape character in R. So if I want to actually produce a backslash, I need to use 2 backslashes to actually have that show up in a character string. All right, so we need to know where that file exists at so that we can either set the working directory there or we're going to be able to supply a path to that file in a different way. But once we can figure out how to tell R where that file exists at, how do we use the read_csv function to read it in? Well, here are the common arguments that you might be changing when you whenever you use this read_csv function. The first one is file. So this is the one where you give it the path to the file. And so if your file exists right in your working directory, you can just give it the quoted string of that file name. That's easy to do. There's an argument called call names, which by default is true, which means that the first row of the raw data file corresponds to variable names. And then there's some other options that you'll see come up. So capital NA is the missing value indicator in R. And so by default, the values that it's using for missing values is a capital NA and just nothing. So if there's something that's just like 2 delimiters in a row, it'll count that as a missing value. However, some other software might use a period, for instance, as a missing value indicator. So you can specify more than just these values to indicate missingness. And then there's the skip option. So if your data starts on like line 5, you might want to skip the first 4 rows. You do skip equal 4, it skips the first 4 rows, it starts on that 5th one. And then call types. This read_csv function is very smart. It's going to try to figure out what kind of columns it's reading in by itself. So usually you don't need to specify this. It's going to guess at that by looking at this option. So it's going to guess using the first 1,000 rows of data what type of column each one is. But again, these are the common types of arguments that you might change when you go to use read_csv. Let's just assume for now, for ease, that neuralgia.csv, the raw data that we want to read in, exists within our working directory. Well, then the first argument that we were going to give read_csv is just the path to the file. And so I'm just going to give it the path to the file. I'm already looking in my working directory by default. So if I just give it the path to the file from there, which is just the name of the file in quotes, that's all we need to do. And so I'm going to save this in an object called neuralgia data. Ooh, there we go. All right. We have a neuralgia data. This looks very different though. This is not looking like the output of any data frame or anything that we've done before. And that's because this is actually what's called a tibble. And so a tibble is a special form of a data frame that the tidyverse uses. And we'll talk more about that in just a second. Now, another way to read in the data other than if it's already in your working directory would just be to use a full path to that data file. So if my file exists within the datasets folder here, I can just give it the full path to the neuralgia.csv file, and that's another way to read it in. Alternatively, what we saw earlier was that R can pull from a URL, which is quite handy. So I could just feed it as the path to the file as long as I have an internet connection. I can give it the path to that file located via a URL. So this neuralgia.csv file is also located at this website under this file name. All right, so let's talk a little bit about this tibbles idea. What is a tibble? Well, remember that we have different functions that we can use to figure out what kind of object we have. If we look at the class of this neuralgia data object that we just created, we'll see that it is a class data frame, but it's also a class tbl, tbl_df, and spec tibble, essentially, right? And so this actually has a number of different classes associated with it. And so if we look at the structure, it looks a lot like a data frame because it is truly a data frame. It's just also got some other stuff going on. So it's 60 by 5, et cetera, et cetera. So tibbles are data frames. They're just special data frames. And so why do we have these tibbles? What is the point of using those? Well, they are the main object that the tidyverse works with. And one thing that they do is they provide fancier printing. You might have noticed a couple times that we typed a data frame into the console and it just printed out all the values and it was really hard to look at. Well, tibbles by default have a nicer version of printing. And so what they do is they print out that it's a tibble. They give you the number of rows and the number of columns at the top. And then it gives you the variable names followed by what type of column that is stored there. And so, of course, checking column type is a basic data validation step. Did I read my data incorrectly? Well, I know that age should be a numeric variable. Well, this is a double variable. That's a double point precision variable. So I know that that is a numeric variable. So that read in probably correctly. Duration, yes, also double. Pain, no, yes, no variable. So that's a character string variable. Great, that read in correctly. And notice that it does not print out all of the rows. It prints out as many as it thinks it can fit. By default, it's like 10. And then it just says, hey, I got a bunch more rows. And if it can't fit all the columns, it'll also say, hey, I got more columns, and here's some information about those other columns. So that's the first big difference between a tibble and a data frame. Tibbles have fancier printing. The other main thing is that tibbles do not simplify. We saw whenever we were subsetting certain parts of a data frame that we would get returned a vector. Right? So if I look over here on this right-hand side, I have neuralgia data 2 that I'm creating. I'm actually using this function to take the neuralgia data and coerce it explicitly into a data frame. So then turn our data set, so turn our tibble into a data frame only. And so by doing that, it loses all that special fancy printing and everything else. And if I now just look at the first column, remember that square brackets allows us to index a rectangular object. First thing I give it is the rows. Second thing is the columns I want. So I want all the rows first column. This simplifies to a vector. So this is doing simplification when we don't ask it to simplify, right? However, over here, if I'm working on a tibble and I do the same exact thing, and I say I want the first column of a tibble, even though it could simplify this to a vector, it does not. It will always return a tibble unless you specify otherwise. And so this is programmatically a better thing. You want to know what type of object you're going to get back every time you do this kind of thing. Every time you subset your columns, you want to know that you're going to get a tibble back. Not sometimes I'm going to get a tibble, sometimes I'm going to get a vector. Because that can make programming a little bit harder. So how do I get returned just a single column from a tibble? Might be a question you have. And so one option is to use the pull function from dplyr. So remember that dplyr is one of the packages from the tidyverse, and that using the double colon operator is a way to call a package specifically from a function. I said that backwards. To call a function specifically from a package. So I'm going to say from the dplyr package, use the pull function. So I've read in the dplyr library here, so I don't need to do that, but I'm going to say pull from neuralgia data, the treatment column. And what that does is it just returns it in a simplified form. Alternatively, you can use the base $R $ as well. That will still return a vector. Okay, so we now know how to read in a basic CSV file. We know that it's going to return a tibble. And in fact, all of the functions from readr that you read in data with will return a tibble. Let's just look at a few more examples of reading in delimited data. The next one we're going to read in is called chemical.txt, and this is that space delimited file that we saw before. we can read this in with read_table, which is meant for reading in space delimited data. Now, what's really nice about the tidyverse is that they have written their functions in a very coherent manner. So all of the same arguments that you would use for read_CSV, if applicable, are used in all the other functions. So the same common arguments will occur in read table that are in read CSV. All right, all we need to do is basically specify the path to the file. So this chemical.txt file also exists on the web. Let's just give it the quoted string of that URL, and we've now read in this data as a tibble. Great, and again, it gives us some nice basic data validation tools here. I have 19 observations and 4 columns. I have 4 columns that are all numeric in nature. And so these are all numbers down here, so it seems like it read in correctly. Now, these are probably representing factor levels, and so maybe I want to change the type of variable that I have here, but since they were all numbers, it's okay to read them in as numbers, and we can modify them later. All right, let's move on to a tab delimited file. So that crabs.txt file is also available on the web, and it's a .tsv file. Actually, it's a .txt, but it's a tab separated value file. And again, we'll just give it the quoted string. We get back our data set. Fantastic. All right, let's do a little bit more complicated one. That last data set that we had in those example delimited data sets was not a standard delimited file. So it was a greater than delimited file. There's not a function that exists in readr that will read in a greater than delimited file by default. And so what we're going to do is use read_delim, which is meant for generic delimiter. And what this does is it has one additional argument that the other functions didn't have, and it's the delim argument. And another thing about this particular data set is that there are no column names provided. So no column names. This means that we can't go with the original call_names equal true, which is the default value of that, which says that the first row is column names. So we're going to have to modify those arguments to make sure that we can read in a data set without column names. All right, let's do it. Well, we're going to use read_delim. We're still going to give it the path to the file. So this exists on this website just like the other ones did. And then I need to specify the delimiter. So I'm going to use a comma. My next argument is what is the delimiter of this generically delimited data file. It's a greater than sign, so I'll put that in quotes. And then lastly, if you, I want to specify my column names. And so I'm going to say my column names are year, month, day, home, away, and home plate umpire. And so I had to get that information from somewhere else. That was not available in that file itself. But there we go. We have now read in a generic delimited file without column names. Now, these have all been really nice, clean delimited data files. By clean, I mean there's nothing really tricky going on, and these functions can just read them in without doing anything extra. Sometimes you're going to find yourself with these flat files, these .txt files that have delimiters, but then there's something funky going on. And so sometimes you'll need to read in this non-standard data using these other functions that you see here. And hopefully you can go most of your life without ever running into regular expressions. But generally speaking, if you have to read it in one of these ways, you have to end up using regular expressions to do some text parsing. Not fun. Let's jump into R and read in some delimited data. All right, here we are in R. We'll go ahead and continue that same file. Now we're going to import some delimited data. And we need some delimited data to start with. So on that same website that we were on, the same website we've been reading in data from, there's some other data sets as well. So let's go ahead and read in this air quality UCI.csv file. But first, let's open it and just look at it. So by default, CSV files will open in Excel if you're on a Windows-based computer. So if I open that, I look at the actual data file, I can see that there's actually a semicolon separating these values. Right? So this is not a standard CSV. This is actually a European-based type CSV. So I would want to use read_CSV2 since the semicolon is actually representing the comma here. But what I really need to do is just grab the path to this file. So this is available on this website at this path. So I can right-click on this and just copy that link. And now it's going to copy this URL plus air quality UCI.csv. So back into R, again, I would need to read in either the tidyverse or just the readr package. I'll go ahead and read in the entire thing. And so again, it brings in 8 packages itself, and it says that, hey, I do have some conflicts here, so be careful if you're trying to use some stuff from these other packages. Now I'm going to read in a .csv semicolon delimited file. And so I'll use read underscore CSV2. And again, all I need to do is give it the quoted string to that URL. So I'll just put quotes and then that URL. And let's save this as air quality. Oh, I should stick with upper camel case or lower camel case, whatever it's called. So I read that in. Let's go look at the messages it sends me. So it says, hey, I'm using comma as a decimal, which is what European stuff does, and period as a grouping mark. So it's just letting us know that we used read underscore CSV2, so be careful. You can use this other function for more control. It's read in 9,471 rows and 17 columns, and there were 2 character columns, 13 numeric ones, and 2 logical columns, it looks like. And you can see it's created this air quality object up here. If I type it in down here, it prints out. Let's widen this a bit. There we go. So it prints out and shows me, hey, these are my columns. And here's one nice thing that read underscore CSV does versus the base R stuff. These are non-standard column names. And so these would cause problems in your base R way of reading these in. But you can see that these have been read in. They're just surrounded by backticks, which is a little bit annoying, but at least it read in correctly. If I want to gain access to those types of columns, let me see, I put in air quality, I put my $, and you might notice it still lists all those columns here, but if I say hit tab on this one, it actually puts that variable name in backticks. So that backtick is usually a character in the top left of your keyboard. So those are a little bit funky in terms of the variable names. They're non-standard names, so they have to have backticks around them. We'll see how to use dplyr in a little while to be able to actually rename our variables so that we don't have to worry about these funky names. All right, so that's one file that we've read in. Let's go ahead and look at reading in another file. In this case, we'll go back to that website, and there's this mosquito.txt file. If I click on it, okay, it's a text file, so it's a delimited file in this case, and it looks like an ampersand is the delimiter. So that's great. Let's go ahead and copy this URL, and then we'll jump back into RStudio. And we could type in the read delim code ourselves here, but let's also see some other things that R can do. So RStudio gives us this import dataset wizard, which I don't ever use, so this might be a little bit funny for me, but we're going to read in text from the readr package. So we could use the base R stuff, but we're going to use the readr package. And then we got to give it the file or URL. So this is essentially specifying the path to the file. So I give it that, and I hit update, I guess. And it shows, okay, so this is what my data looks like. And it says, well, right now I'm reading this all in as one character variable. So I'm not reading it in correctly at this point. I can specify skip, all this other stuff down here. What I really need to do is say what the delimiter is, right? So it's not a comma, it's something else. It's not a semicolon, tab, white space. And so I can put in an ampersand here, hit OK. Let me update that. There we go. Oh, hey, that's looking like it's reading in pretty good. So I got my day, cage, treatment, and response, and the variables look like they're reading in correctly. And so now I can go over here to code preview, and you can see it's actually giving me the code that's used to read this in. So what I can do is just copy this, and I don't need the library readr because we've already read it in the tidyverse. So I'll just copy that bit. Notice it's already giving it a default name as well based off of the file name. So we're going to create a mosquito object. I'll hit import. Now it shows me this mosquito object, and I have that in my global environment, but it did not save the code automatically there. So what I'm going to do is I'm going to make sure I paste that code down here so that I have it for later use. You want to make sure that everything that you do is reproducible, so you definitely want to be saving that code. So this is reading in a ampersand delimited file using the wizard. But that's how easy it is to read in nice, clean, delimited data using R and RStudio. All right, just to recap, we are going to be using the tidyverse from here on out for the most part. And so we got this readr package within the tidyverse that has a bunch of great functions for reading in delimited data. And what's kind of nice is that all of them use these same common arguments So once you sort of get those down for one of these, you run into another type of delimited data. You can basically apply all of those same things.